For this example, let's solve for y in this literal, what I call alphabet soup equation of my squared minus xy plus m plus 6 equals 0. Now it's really important to recognize which variable we're solving for here and how it's behaving, since y is squared in our first term, is a linear term, so y to the 1 in the second term, and there are no y's, so basically a constant in the rest of it, we have a quadratic equation when solving for y in terms of y. I have no idea how to factor this. There isn't a common factor in all these terms. So since it's a quadratic equation, I'm going to use the good standby, the quadratic formula. So y equals negative b plus or minus the square root of b squared minus 4ac over 2a. Now I know you're used to it being x equals, but it doesn't matter. Whatever variable is playing the part of the quadratic variable in our equation is free to be solved using the quadratic formula. So the only thing left to do is to figure out what our a, b, and c are and plug them in. So remember, a is the coefficient of the squared terms, so a must be m in this case. B is the coefficient of the linear terms, so including the negative, so b must be negative x. And c, in this case, must be our constant term that doesn't have y's with it, so c must be the entire set of terms m plus 6. And now all we need to do is plug those in. So we have y equals negative b will be negative x, plus or minus the square root, b squared would be negative x quantity squared, so x squared, minus 4ac, a is m, c is m plus 6, and then all over 2a, and like I said a second ago, a is m. Now there's not a lot of simplification that can happen here, so let me just clean this up just a little bit. Y equals negative x is x, plus or minus the square root of x squared, minus, I guess we could distribute, so negative 4m squared minus 24m all over 2m. And as tempted as I might be to simplify the square root of x squared, the square root of 4m squared, even the 24 portion here, because we have these subtraction signs inside our radical, they're not free to cancel in the square root. We'd have to do some factoring. And none of this factors inside the square root, so we are finished. One last thing to point out is if we had been solving for a different letter in this literal equation, in this alphabet soup equation, since none of the other letters have a squared with them, then we wouldn't use the quadratic formula to solve for m or to solve for x. We would simply collect all of the terms with that letter on one side, factor it out, and get everything else on the other side.